Okay, carrying on with dependent events, I'm going to question 5. Question 5, page 136. I said that these will be shorter videos because you need to concentrate on them, give them their own due respect and time for them just to be absorbed into your thinking and become sort of natural in a way. So the probability, question 5, page 136. The probability that Mr. Metcalf sleeps through his alarm is 0.09. So here we go. So let's put the word sleeps there. So he's going to sleep through. That's going to be 0.09. Pretty low probability, really, isn't it? If he sleeps through his alarm, the probability that he will miss breakfast is 0.72. So we're going to miss breakfast. .72. So this is the conditional probability. So if he sleeps through, quite a high probability he's going to miss his breakfast. So that links to that. If he does not sleep through, then the probability that he will miss breakfast is 0.26. This is the other condition as attached to not sleeping through. There you go, is 0.26. So he's not going to sleep through, so there's a much lower probability of him missing his breakfast. It makes sense. I've now got to go and create a tree diagram out of this. So what are the options? I can sleep through, call it ST, or not sleep through. So if I'm going to sleep through, I'm going to be, let's just use decimals, no point converting to fractions. That's that one. So probability of not sleeping through is going to be 0.91. Remember, both parts of the branch add up to 1. Back to red. So I can sleep through and I could miss breakfast. Let's call it MB, shall we? Keep it consistent. So I'm going to miss breakfast, or I'm not going to miss my breakfast. Same conditions apply. You could miss your breakfast if you don't sleep through, or you can not miss your breakfast. Now let's get the probabilities on there. Blue. So if I sleep through 0.09 and I miss my breakfast, that's going to be 0.72. That's the condition. So therefore, if both branches add up to 1, then the chance of sleeping through and not missing breakfast will be 0.28. Okay, fair enough. So sleep through and not missing breakfast, sleep through and miss me breakfast. Now, not sleeping through, 0.91, and if I don't sleep through, in other words, I get up at the proper time, I could still miss my breakfast, but the probability goes down to 0.26. So 0.26, and I can not miss my breakfast. That'll be 0.74. So that's the grade A stroke A star tree diagram set up. That's going to get me some marks. It says use the tree diagram to find the probability that Mr. Metcalf sleeps through his alarm and misses breakfasts. Sleeping through the alarm and misses breakfast. So here I go. I'm going to go 0.09 and miss my breakfast, 0.72. That's definitely screaming out for a calculator, that is. So 0.09 times 0.72, that gives me 0.0648. I really don't want to round it just yet. I may not round it at all. Next part. Use the tree diagram to find the probability that Mr. Metcalf does not sleep through his alarm and does not miss his breakfast. Well, that's this one. I'm not going to sleep through and I'm not going to miss my breakfast. That's a proper normal day. 0.91 followed by not missing breakfast, 0.74. That's going to give me whatever my calculator says. 0.91 multiplied by 0.74. That's going to give me 0.0634. I'm quite happy to leave it just as it is, I really am. So that's my probabilities. Oh, I made a mistake, I misread my calculator. Do it again. Misread, it's dark. Right, it's actually 0.6734. Apologies to everyone who's watching this video now, but that's correct. Alright, that's Mr. Metcalf. I want to do question 6 and then pause for another video. So let's just change pages now. Right, that's good. Right, question 6. A bag contains 90 balls. Put a 90 up here. And I've got red and green in the ratio of 4 to 5. Okay then, 4 to 5. Red and green, that's how I like to set up my ratios. Red and green, 4 to 5. And these are balls presumably in a bag usually. The balls are drawn at random. Use a tree diagram to find the probability that one of each colour is picked. Okay then, so what are the options? I can go red or green. If I get a red, I could get another red one, or even a green one. If I get a green one first, I could go red, followed by green, and that's the stick set up. Now, if I've got the ratio of 4 to 5, clearly I've got 40 reds and 50 greens. That's a nice, easy, kind ratio. That adds up to 90, doesn't it? So I know I'm correct. Right, let's put these jolly old probabilities on there. What's the probability of getting a red? Well, I've got 40 over 90, and the 50 over 90 will be the greens. Could simplify this, I really don't want to do that. You'll see in a minute why. Now, if I pick one red, I've got one less ball left. I'm out of 89 now. And if one of those reds has gone, I'm down to 39. So I'm jolly glad I didn't have to simplify anything. Right, I've still got 89 balls left here, but the greens are still intact, therefore I have 50 of them still waiting. If I pick a green first, I'm down to 89 balls, and I've not taken a red one yet, therefore I have 40 there. If I take a green first followed by another green, I'm down to 89 balls, so I've taken one out. If I had 50 greens, I now have 49 greens sitting there. Let's have a look, just check. 39 plus 50 makes 89, so that's correct. 40 plus 49 makes 89, that's correct. All the branches add up to 1, because all the probabilities of dependent events will add up to 1. Okay. Right then, here we go. So, what's it say? Use your diagram to find the probability that one ball of each colour is picked. Well, let's go for yellow. I can go red followed by green. In other words, probability of red, green is going to be 40 90ths followed by 50 89ths. I'll work you out in a minute. Or I can go green followed by red. That's one of each colour, which is 50 90ths followed by 40 89ths. Pick up my machine. I've got 40 ABC button 90 multiplied by 50 ABC button 89. Oh, that's unbelievable. Right, that's 200 all over 801, and this is going to be exactly the same, but look, it's just been reversed around the other way. So that's going to be 200 over 801. I'm going to put the total up here, and actually let's go over here. I've got therefore 400 all over 801. Just in case it simplifies, I'm going to try it anyway. It certainly does not. So the probability of getting a ball of each colour in any order, as long as it's red followed by green or green followed by red, is 400 over 801. And there's your answer. And I'm definitely going to pause that because that's complicated.